So what does twinning definition mean? So we'll start with the crystal definition. So crystal is regular arrangement where the unit cell can be infinitely repeated. Then comes the crystal growth. So when the energy state is low, which is good for the crystal growth, and offset during the growth may cause the intergrowth pattern. So whenever there is offset during the growth, then intergrowth pattern occurs, and that causes the twinning. Now, what is the Bravis law? Bravis law says that whenever there are points, then the face will form where the density is more. Means these vertical faces will form rather than these oblique faces. There is also called Steno's law of consistency, which says that the crystal forms the uh, equal angle even though when they are deformed. So if the length of this hexagon is increased to like this, then also the crystal face will form the equal angles. And then comes the twinning. So twinning is offset of the atomic arrangement lead to the non-random growth. So twinning is crystallographically controlled intergrowth of same composition with the rational and symmetrical relation between the lattice direction. Twinning can be considered as a planar defect. Then comes the epitaxis. So what is epitaxis? So epitaxis is a non-random crystallographic orientation growth of one crystalline substance over another. So here it is staurolite and canite is growing over the staurolite. So this is called the epitaxis. Now type of twins. First comes the growth twin. Means when the crystal is forming, at that time if the emplacement of atom uh, occurs during the growing, then the disruption occurs and the twinning crystals are related to the symmetric element absent in the original untwinned crystals. So the twinned crystal have the symmetric element which the untwinned crystal don't have generally. What processes occur for the growth? Reflection, rotation and inversion, the same element of symmetry that we have seen in the symmetries. Then comes the annealing or transformation time. So when the crystal is cooling down, at that time annealing or the transformation twin so occurs when the crystals become unstable during the cooling, and these crystals reorganize on the transformation into more stable form, generating the crystallographic related twins. Then comes the deformation or the gliding twins. So these occur due to the stress condition, and that generally occurs in the metamorphic situations. So formed due to the stress experienced by the crystal after its formation, and commonly found in the metamorphic rock. And these twin classification in the crystal can be as contact twins. So this is the spinel law, this is the Japan law, and this form generally we dipyramid structure that we see in the hexagonal as well as the orthorhombic structures we see generally the dipyramid. This is HKIL kind of structure. Then comes the uh, penetration twins. So now we are twin classification in the crystallography we are studying. Then comes the penetration twin. So when one element or one crystal is penetrating into another, so this is fluorite, this is pyrite, these are the ortho class. So interpenetrating crystal with an irregular composition surface are the penetration twins. First is the Japan law is the Japan law was the previous one. Then comes the interpenetrating cube of fluorite twin, that is 110 as twin axis. Then comes two pyritohedral crystals forming iron cross. This is the iron cross penetration twin with the twin axis interpenetrating crystal as 180 degree. Then comes the uh, orthoclass exhibiting Carlsbad twin. So this is the Carlsbad twin we generally see in the monoclinic, which two interpenetrating crystal are twinned at 180 degree about the C axis. This is the C axis 0, 0, 0, 1. and this is the same orthoglass crystal 0 0 1. Then comes the repeated twins. What are the repeated twins? So after contact twin, penetrating twin, we see the repeated twins, multiple crystal twins on the same law. Then comes the polysynthetic twins, multiple parallel composition phase, generally shown in the Albright law by Plagioclas. Plagioclas. And then comes the cyclic twins, non-parallel successive composition of aragonite or rutile. So these are the cyclic twins. Then comes the, so this is the polysynthetic twins. Then these are the cyclic twins we have seen. Then we see the twin laws. So what are the twin laws? The twin laws are, first is for triclinic system. So triclinic are what elements are triclinic? The triclinic elements are the feldspar as well as the microcline, and they follow Albright and Pericline law. What is Albright law? 0 1 0 plane. Twinning occurs along the 0 1 0 plane in the feldspar. This twinning is so common that it is used as the diagnostic property of the film. So Albright law is the diagnostic property of feldspar that we need to remember, and that is 0 1 0 plane. That is very important. And then comes the Pericline law, reading along the 0 1 0 axis. So for triclinic system, if we want to remember, then we need to remember that what the elements are, what the twinning law that it follows. That follows A and P. A is Albright, P is Pericline. It follows 0 1 0 plane, it follows 0 1 0 axis, and this is commonly occurred in feldspar, and this is triclinic feldspar. The cross-hatch or tartan patterns appear. So these words like cross-hatch pattern in the Pericline law or in triclinic system, if we write these elements, then the things become more clearer to us. And then comes the monocline. It has MCBS, means Manebach, Carlsbad, Bhavana, and Storolite. So first we see the Manebach law. The Manebach law is, it was 001, it was 010, it is 001 plane. Then comes the swallowtail. Swallowtail is 100. This also occurs in the alkali feldspar, Manebach, and the swallowtail occurs in the gypsum. Then comes the Bhavana law. So Bhavana law is 021. Here it is Bhavana. This is Manebach law. Manebach law we must have seen the diagram. Manebach law must have seen the diagrams. So this is Manebach law. This is swallowtail law. This is Bhavana law. And this is Carlsbad law. Carlsbad occur in K feldspar, Bhavana is 021. So if we remember, try to remember it. So first is Manebach. So Manebach has the plane of 001 we need to remember, and this diagram we need to write. Then comes the Carlsbad. So Carlsbad has 001 axis. 001 axis. This is C axis. And then comes Bhavana. Bhavana has 021 plane. 021 plane. And then comes the swallowtail law. This is 100, opposite of 100, 100 plane. So these things we need to remember. This is very important, monoclinic. In triclinic we had Andhra Pradesh, AP. A was Albright, B was Pericline. It was also in feldspar. It was also in Pericline we used to have cross-hatched structure. Then comes the orthorhombic system. So in orthorhombic system we have a twin plane, that is 100. Where we had the 100, we had the 100 in the swallowtail. So orthorhombic is also showing similar to the swallowtail. swallowtail. So the twin plane commonly with the prismatic phase, the most common is 100 twin resulting from the orthorhombic mineral, and the cyclic twin aragonite, chrysoberyl, and sasurite. These show the pseudo-hexagonal appearance due to the 110 plane. Then it has the staurolite cyclical twin law. It has the staurolite twin laws. So although staurolite is monoclinic, its beta angles closeness to 19 degree is pseudo-orthorhombic appearance, and it is commonly display two type of penetration. First is 031 and then 231. So to see them, staurolite, this one is staurolite, and this is the contact twin. So this 031 we need to see. So it has two forms, 031 and 231. Then comes the tetragonal twins. So sassiterite and the rutiles show the twinning. How to draw these diagrams? These diagrams are very important in tetragonal. So plane is 0, 1, 1 type of, and crystal are sassiterite and rutile. Then comes the hexagonal system. So it has CBDJ, means CBDJ. So DJ came back. So what is C? C is calcite. We know that hexagonal has a beryl type as well as the calcite type of crystal. In beryl we have so many DPP and BPP and D3. The prism of first order, prism of second, dipyramid of first order, dipyramid of second order, hexagonal dipyramid. So these crystal we have generally. In calcite, CBDJ, hexagonal, we need to remember. Dauphine and Japan is important. This Japan diagram is very important. This is Dauphine diagram, this is Brazil law, and these are the calcite twins. Then comes the isometric kingdom, isometric system, which has iron cross law and spinel law. A spinel law we have seen initially, but again we will see the diagram that how to draw the spinel law. So spinel law diagram is very important. First you draw a triangle and then make a rhombohedral, then copy that rhombohedral, join this, and it is over, and join this, and 1 bar 1. So spinal, if you are writing, then it will be over. So this